So here we go, cognitive load theory, something Dylan William called the single most important thing for teachers to know. And it's all based about the model of memory in which things enter into our short-term memory and are transferred to our long-term memory. Learning is change in our long-term memory. And within our short-term memory, we talk about working memory as being the things that we are manipulating in our head at any one time. Working memory varies in estimates of its capacity from anything from 2 to about 7 things that we can manipulate at any one point. And cognitive load talks about the strain and the capacity of our working memory. That might be through various routes. It might be through intrinsic load in our working memory, through extraneous load, and through germane load. Intrinsic load refers to the actual complexity of the task you're doing. So for example, in driving, all of the things you're having to hold in your head when you press the clutch pedal, when you move the stick, when you're looking around you, all of these things are part of the intrinsic load of the task. Extraneous load is things that also our working memory is being used up on but are not essential to the task. So for example, if you're highlighting something and you're thinking about the colour of pencil you're using, then that is using up some of your working memory. And germane load is what is referring to the actual transfer of things from working memory to long term. So making those connections that secure something in long term memory. So germane load is actually a really important one that we want to maximize so that we maximize the learning that's happening. And to do that, we have to reduce intrinsic load and extraneous load. To reduce intrinsic load, we can do this through reducing the complexity of the task. In a study of expert chess players, they discovered that what really mattered to becoming an expert at chess was not your IQ, was not your problem solving, but was your domain specific knowledge. In other words, how many previous games you'd seen, how many chess moves you'd memorized, and so on. And the same with maths. If you memorize lots of number skills, lots of strategies, lots of processes, then that reduces the intrinsic load of learning something new. Breaking down learning into small steps as well makes sure that there's not too much overwhelming working memory at any one point, and through scaffolding too. Then of course we can reduce extraneous load as well. If there's presentation of materials in which there's lots of illustrations and colours that are distracting pupils, then that takes up working memory that they're going to need for transferring learning to long-term memory. Or if there's emotions going on, if they're angry or hungry, then that will take up some of their working memory. Or if there's maths anxiety, and the classroom layout and how many distractions and noise might distract them too. If you're interested in finding out more about this, there's a book here by Craig Barton I'd highly recommend. It's a very, very useful book that goes into some of the psychology of these things.